Let's go. So we're importing our lambdas and checking out our data. So this is a little bit unique in that they actually have tables set up for us in the beginning. So I'm just going to rename some of this stuff. All that can stay. This is going to be called costs. Let's rename to the proper way of spelling color and cost. This section we'll name coats, dancers and formations. Let's call this table F. And there we go. I think we're good to start. Okay, so we want to know how long the coats are, so let's look up the coats. So we're going to look up coat name in the first row of coats, and then return the whole column. Let's call it so that we get rid of the blanks. And then we can just count A minus 1 to get rid of the header row. Okay. Alright, now we want to know which color appears most often. We have a lambda for that. So just come out here and change this to most of. And for this one, we want to know the total cost. So we'll just take the values and then look it up into the cost table. It's going to be costs, color, costs, cost, and a 0 for error handling sum amount. Okay, this time we want to take the attribute scores. Okay, so over here, let's name these headers as ATT for attributes. We gotta pull these in based on the name. Okay, so we'll say XLOOKUP. Oh, we're gonna have to do this for each one and then find out which is highest. Okay, so I'm gonna do it like a lambda. Given a coat name, we'll start with this pastel pink fluff. But given a coat name, then what are the values associated with that? So that's T name. And then we're going to drop T, the first two columns. So those are our values. Now we need to apply modifiers to them. So times ifs. So if it's in the priority bucket, then we'll say is number X match. Attribute label is in text split this. If it's in there, then we want to multiply by 2. Now we'll take that same logic, only change this to the ignored one. So if we're ignoring it, then multiply by 0, otherwise multiply by 1. So that gets the total, sum those up. And that's a lambda now. So let's make it a lambda v for the coat name. And now we can map each coat name. Map with T name. And so those are the values. We'll do a rank by. These are our values. The names are here, and we want the highest one. So let's pastel pink fluff. There we go. Okay. Now we want to know the ecstasy effect. So 200 divided by the distance. So first we need to know where each of these people are. So given this formation, we'll lookup this formation in F name, returning the humble MVP, gives the address of where Giles is. And then the dancer location is going to be a T lookup, table all index is this, dancer is that. So that's our dancer location. And then the distance, let's see, ecstasy. Is going to be equal to 200 divided by cell distance, this cell and this cell. And the way we're calculating distance is sort of close to Pythagorean, but not exactly. 1.4 for a diagonal instead of the square root of 2. We'll just round this to 0. And that should be our answer. There we go. Alright, now we need to name the different formations. So over here, there's a visual representation of each formation, but it doesn't give the name. So we need to check the name based on the values in this table over here. So I'll say equals if left this equals F, then let's see, address will be to call addresses. We're going to go from B2 to P16. B2 to P16. By value. So that's addresses. The values are going to be to call, and then whatever's down here, that range. We want to filter on just where the dancers are, so we'll say filter addresses on values, and then sort those. We'll sort them because we're going to sort these row by row and compare. So that's what we'll do next. We'll say by row F, which is that whole table, for each of those lambda row. Okay. Now for each row, we want to sort to call it, and then drop first 3 columns. So that's the sorted ones, and we want to see is every single value equal to the filtered values. So and for every single one, and then this gives, so this total thing will just give an array of true and falses for each name, and then we can filter on the name. So filter F name on this is true. And initially we get NA, we get a wrong answer. We didn't find this one. So I wonder, did we drop? What are we doing wrong? Values. First let's see what we're getting for each intermediate step. So the filt looks like it's working correctly, it's giving values. Final is not. Okay, so our error is somewhere in here. So by row F lambda R, we're dropping the first 3, 1, 2, 3. And that this is to call and it's sorted. So is the filter. So if each value is that, then and. Let's see where we're at just before doing the filter. We're still NAs. Why are we NA? So drop R3. Filters here by row. To call. Sort them. Let's sum. F by row lambda R. Then we're gonna say drop R. No, let's go into Lambda Explorer. Sorting works. It's 44. Filter. Oh, there's an extra filter. Okay, I don't. So we weren't supposed to filter out humble MVP, so we only want to drop 2. That's what the problem was. Okay. And now I'll change this back to end. And filter. Alright, so now that that is good, we'll come down and paste it on all of these, and then we'll put in the formation number in here. So equals X lookup on that, look for it here, return the formation number here. Okay. Now we'll say X lookup, formations, F num F name. Good. Okay, so on this one, they want to know where Giles ends up, or actually not just Giles, but any dancer. So a dancer does a particular move, and each one goes a certain step and directions. Okay, so ARR transpose ARR. We just want access to these arrows. So for I is for MVP, we're going down 2. So I'm going to make a concatenated value here, just 2 downs. The slide is going up and left 3 times. So we'll do that. The L is for love, is going down to the right 2 and then down 1. So this times 2 and then down 1. Now for this last one, it varies. So it could, depending where you're at, but it always goes from where you're standing to row 2. So that one will handle slightly differently. We'll have to handle that, yeah, on its own. So here we are. We're gonna say, call this moves, and this M. Okay, so now we will, what do we have to do? Look up where the dancer is. Table lookup F for that formation and that dancer. So that's the location that we start at, and then we'll take address offset. So we start at this address, and then we're going to move using the arrows. So we'll X lookup our dance move in M and return moves. Concatenate those, address offset, and we want the last one. That's where we end up. However, on the fallback, so we'll say if dance move equals fallback with an anchor, then we're going to handle that differently. It's going to be address row 2 and then whatever column we were in here. Like that. Okay. Good. Alright, so now the bonus is, what is the total length of all the for codes? So we had a formula for length over here called this coat length. Let's turn this into a lambda. Let's see. Say lambda, yeah. We don't need this as an input. Let's make that a step. So coat length, and now we can just map all the coat names using coat length. There we go. In how many of the dance formations am I front and center stage? Oh, Giles. We're gonna sum that wherever the humble MVP is at I-16. That's a good question. I need your help to find which dancers enjoyed my company the most. So this time we're using the songs. So we have these songs. Let me just get a filtered list of the formations we're using. So filter D. No, I want D. Wherever C equals dance formation. Okay. Now we need every single dancer. So let's get those from this list here. It's the dancer names. We might as well just get their addresses. Oh no, okay, so the addresses are going to be based on each formation. So we have to say xlookup formation, and then we want to return what? Let's see, we're looking that up in name, and we want to return F, but dropping 3 columns. Okay, so I have to do this one by one. Like that. Okay, so those are the addresses. Let's actually, you know what? I need Giles' address too. So let's just drop 2 and move it over 1. So that's the MVP. Yeah, just move all these. Okay, we're good on that. Now, let's again with these, and then we're gonna map. Let's see. The distance is gonna be cell distance between this and this. That has to anchor to the column. And then x to c is 200 divided by that. Okay, so that's all those. Let's insert a column here. Okay, so now let's just get the highest one. Use rank by. Here's our totals. Here's our names. And equals round to 0. Okay. What is the name of the dance formation we've so gracefully pulled off in the main stage? So here's the formation here. It's a G. We just need to match that to E's. Looking for the G here. Here's our G, and that's Mr. Humble. Alright, for some inconceivable reason, okay. Using level 5 rules, what is the total distance traveled by the entire dance crew, including Humble MVP, when moving from group hug to what did I say? Okay, so we'll just map the locations. So it's going to be xlookup group hug, and we're going to look up f name return drop f 2 columns. So that's all the positions of the first formation. We'll also map all of the locations of the second formation, which is what did I say. So we'll map each of those, lambda x, y, and then do cell distance x, y, 1.4. So that's the total distance, and then just sum all those, and probably have to round that to 0. There we go. Favorite drink. Okay, let's look for drink. Find all. Right here we see Guinness. Spelled it wrong. And done. Voila. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.